All right, welcome back to the deep dive. It's that time again where we take a stack of sources, articles, research notes, and really dig into something fascinating.
Yeah, settle in.
And today, we are plunging into the world of AI image generation, specifically a brand new development that honestly promises to fundamentally change how we interact with these creative tools.
That's right. We've got a good collection of materials today. It gives us a really clear look at this new tech. We're primarily drawing from documentation provided by Black Forest Labs themselves, who developed it.
Okay.
Plus, we have notes from one of their key infrastructure partners, Fail, and even a description of an online tool built around it that lets users get hands-on.
Right. So our mission today is to really unpack what this technology, it's called FLUX.1 context, actually is. We want to move beyond the marketing speak, understand exactly what it can do, how it achieves these capabilities, which, yeah, sometimes feel a bit like magic, and most importantly, why you, our listener, should care about it. Think of this as getting a truly clear, in-depth picture, no pun intended, of a complex new tool and, well, its potential impact on creative workflows.
And there are some truly fundamental shifts happening here. It goes well beyond just, generating a static image from a text prompt, which is what a lot of people are familiar with.
Right, that basic text-to-image.
Exactly. The core idea they're really championing is about generating and editing images in context. And the key part is using both text instructions and existing images as the starting point and guide.
Yeah, that combination of text and image input feels like the real differentiator here. It's not just one or the other.
Precisely.
They talk about enabling things that were, frankly, incredibly difficult or impossible with AI alone before. Things like consistently maintaining a character's appearance across multiple scenes.
A huge one.
Making super fast, targeted edits within an image and integrating text seamlessly. It really does feel like a significant step beyond those traditional text-to-image models.
It certainly does. I mean, it tackles some of the persistent challenges that creators have faced when trying to use AI for anything more complex than just generating single standalone images.
Okay, so let's start with the fundamental question then. What is FLUX.1 context at its core?
According to Black Forest Labs, it's a suite of generative flow matching models.
Generative flow matching models. Okay, that's a specific technical term. Can you unpack that a little for us? What does flow matching imply about how it works compared to, say, the diffusion models we've heard so much about?
Absolutely. So think of many previous generative models, like diffusion models. They often work by gradually removing noise from an image to reveal the final result, or sort of adding noise to scramble it.
Right, that's step-by-step refinement.
Exactly. Flow matching is a newer approach. Instead of those steps removing noise, it tries to learn a direct flow or path from a simple noise distribution like static to the complex target data the actual image data. Essentially, it learns a more direct route from noise to a clear image. And this direct mapping can potentially be much faster and maybe more stable than the iterative steps of diffusion. It's learning the transformation path directly.
Ah, so it's about finding a more efficient, perhaps even smoother way to go from randomness to a structured image. That aligns with the speed claims we see later on, right?
Exactly. It's about finding that optimal transport path for the data, you could say. But the real innovation they emphasize, the part that gives it the context in its name, is this idea of in-context image generation and editing.
And as we touched on, that means it's not just taking text prompts.
Precisely.
Yeah.
Unlike many previous models that primarily relied solely on text prompts and describing everything you want from scratch, FLUX.1 context is designed from the ground up to take both text and existing images as input simultaneously.
Oh, together.
Yes. It uses these inputs together to understand the desired outcome and then guide the generation or modification process.
So if I have a photo of my dog, I can give it that photo and a text instruction like put a party hat on him, or maybe change the background to a beach.
Yeah.
It's not just generating a new image of a dog with a party hat, it's working with my specific dog's image.
That's the core idea, yes. It basically unifies two functions that were often separate or frankly cumbersome before. Instant text-based image editing, which is where that image input is key, and classic text-to-image generation.
Okay.
And because it handles these different types of inputs and tasks together, it's described as a multimodal flow model.
Multimodal, meaning it's designed to inherently understand and work with multiple modalities of data, like text and images, in a combined way. It's not trying to convert the image into text or vice versa. It's processing them in parallel or jointly.
Exactly right. It's built to see and understand both forms of input right from the start. The overall aim, as Black Forest Labs puts it, is to allow you to seamlessly extract, understand, and modify visual concepts to produce new, coherent renderings.
Coherent is a good word there.
Yeah, the focus is squarely on consistent, context-aware generation and editing, using both text and images simultaneously as the guiding input.
And they have a really memorable key phrase associated with this technology, almost a tagline, that kind of encapsulates this foundational difference.
They do. They use the phrase, your images, your words, your world. It really speaks powerfully to the idea that you are bringing your own visual starting points, your photos, your designs, your existing assets.
Your context.
Your context, yes. Combining them with your instructions expressed in text, and then shaping the digital visual world based on that personal context and input. It highlights the shift from just describing a world to actively editing your visual world.
Your images, your words, your world. That's sticky. It definitely gets the core concept across. Okay, so it's this new suite of multimodal flow matching models. Takes both text and images as input, unifies generation and editing. Let's really dive into what it can actually do. What are the specific capabilities and features that stand out from the sources?
Well, first off, it still covers the classic ground, and apparently does it well, based on their claims. It performs state-of-the-art text-to-image generation.
Okay, the basics are still there.
Absolutely. If you just give it a text prompt, it will generate an image. And they claim strong prompt following, photorealistic rendering, and competitive typography generation, which is often tricky.
So for users who just need to generate images from scratch, maybe for initial ideation, drafting concepts, or just for fun, it still serves that purpose at a high quality level.
That's the message. It's not abandoning the classic text-to-image workflow. It's aiming to improve it while adding these new dimensions.
Right.
But, as we've highlighted, the major expansion, the part that really distinguishes it and gives it the context power, is the image-to-image or in-context editing capability.
This is the big one.
This is where the model doesn't start from noise or a blank canvas, but understands and creates from an existing image you provide.
And the major benefit they emphasize here is modifying that input image via simple text instructions without needing complex layers, masks, or, fine-tuning a separate model.
That's the big promise. It aims to enable flexible, powerful, and instant image editing by simply describing the change you want using text, applied directly to your input image.
So bypassing those time-consuming, complex, traditional editing workflows or separate AI model fine-tuning steps for specific concepts.
Exactly. You give it an image, tell it what to change with text, and it handles the interaction between the two. It's supposed to figure it out.
Okay, let's get into the specifics of these in-context editing capabilities then, because this is where the real practical power seems to lie. The sources highlight several key areas where this approach really shines. The first one, and honestly one of the most frequently requested features in AI image generation, is character consistency.
Yes, this has been a massive challenge for pretty much all generative models up till now. You can generate a fantastic image of a character, maybe.
Yeah, you get one good one.
Oh, right. But then trying to generate that same character in a different pose or a different environment or a different situation often results in someone who looks slightly different, or the clothes change or features get altered.
The consistency breaks down.
Totally. Flux.1 Kontext specifically claims the ability to preserve unique elements, like a reference character's identity or an object's specific look, across multiple scenes, viewpoints, and environments. They use this phrase that the model remembers what matters about the subject you're focused on.
That is genuinely a game changer. I mean, for anyone trying to create visual narratives, comics, storyboards, illustrations for a book, even just consistent branding for a marketing campaign. If you need the same character or product to appear consistently, this capability is essential.
Absolutely.
The examples they give are really illustrative of this power too, like taking a picture of a person holding an apple and saying, maintain the person's appearance in the picture while replacing the apple with an avocado. It's understanding which elements to keep constant the person and which to change the object they hold.
Exactly. Or the even more dramatic example. Maintain the person's appearance and change the background to a forest.
Whoa.
Here, it's preserving the foreground subject's identity while completely changing the entire scene behind them. It highlights the model's ability to kind of disentangle the subject from the environment and focus the editing on the specified area while locking down the identity elsewhere.
Okay, so preserving identity across different contexts. That's huge. What about making smaller, more targeted changes within a single image without messing up the rest? They explicitly mention local editing.
Right. This is about making precise modifications to specific elements or areas within an image without unintentionally affecting other parts.
Hmm.
The key here, they say, is that the model understands the visual context of your specific image
Okay.
and the semantic context of your prompt to achieve this targeting.
Mm.
It's not blindly applying a change. It's trying to understand what you mean by car in this picture and what turning it blue means in that visual context.
So you could take a complex scene and say, turn a red car blue, and it ideally identifies the car in the picture and changes only its color, leaving everything else untouched.
That's the idea.
Or even move a mountain to the background, and it knows which mountain in the image you're referring to and understands the concept of relative spatial arrangement.
Precisely. And they give examples that are even more subtle,
Yeah.
demonstrating what seems like a remarkable understanding of human form and expression within an image. Like taking a portrait and saying, tilt her head towards the camera,
Wow.
or make her laugh. It seems capable of grasping these nuanced changes to pose, expression, or spatial relationships based on your text command applied to that specific image. That level of localized, context-aware modification is incredibly powerful if it works consistently.
That's pretty fine-grained control. It moves beyond just adding or removing objects to actually manipulating existing ones in subtle ways. Okay, another specific capability they list that always feels a bit like magic when AI can handle it well is text editing within images.
It really is a challenging task for AI, right? Because text needs both visual representation and semantic understanding.
Yeah, it has to look right and mean the right thing.
Exactly. They state that FLUX.1 context handles text within images proficiently, allowing you to swap out signs, labels, posters. The key, again, is the in-context part. It identifies the text in your image and allows you to change it via text instructions while maintaining the surrounding image elements and maybe even the visual style of the original text if you want.
So you just tell it what text to find and replace and what to keep around it?
That's the concept.
So you could have a picture of a sign that clearly says, "You had me at beer," and tell it to change only that text to, "You had me at context."
Yes.
That's incredibly useful for mock-ups, localization, or, let's be honest, creative meme generation.
Exactly. Or, in another example they provide, which demonstrates its ability to identify text in different positions relative to an image, changing text below the image from Eeny-Meeny to Flux Kontext image generator and text above from James Gray to Flux.
Ah, so it knows where the text is.
It identifies the specific text strings and modifies them based on the instruction, showing a pretty sophisticated understanding of text elements within or associated with the visual context.
That opens up a lot of doors for designers and marketers who need to quickly iterate on visuals with different copy.
Okay, and then there's style reference or style transfer, which is another common desire for artists.
This is about taking the visual aesthetic or artistic style from a reference image you provide, or maybe describing a style with text and applying it to another image or a new scene you're generating. It aims to capture the unique visual signature, colors, brushstrokes, composition feel, and transfer it coherently.
Like saying, transform this photo into a Ghibli anime style.
Yeah.
It needs to understand the essence of that style, right? And
Yeah.
apply it appropriately to your source image or new generation.
Yes, precisely. Or even more general style changes like go from oil painting to pencil sketch, or modern poster to surreal collage. The model has to understand the visual characteristics that define these styles and apply them in a way that makes sense in the context of the target image or prompt. So we have character consistency across scenes, highly specific local edits within an image, accurate text editing in images, and style transfer, all powered by combining text and image input. But they also highlight a critical capability that sort of stitches all this together, the ability to make these edits iteratively.
Yes, this is a key strength they emphasize,
Mhm.
and one where previous models often really struggled. It allows users to make an edit, look at the result, then add more instructions and build on that previous edit, refining step by step through multiple turns of interaction with the model.
Like a conversation with the image.
Kind of, yeah.
Yeah.
And crucially, they claim it maintains consistency characters, identities, styles, features across these different scenes and viewpoints, even as you make multiple changes in a row.
That multi-turn editing capability, preserving quality and consistency over several steps. That's highlighted as a first for models like this, and is what makes complex visual storytelling or design iteration truly feasible, right? You're not starting over with each edit, you're building upon the last one.
Exactly. Maintaining that visual coherence and identity through cascading edits is a significant technical hurdle. And finally, the sources repeatedly mention interactive speed as a core feature.
Minimal latency for both generation and editing. Why is that level of speed, particularly low latency, so important for these new capabilities?
Well, speed fundamentally transforms the user experience. It goes from a batch process where you submit a prompt, wait a while, get a result,
The old way.
the old way, to a truly interactive workflow. If you're making iterative edits, as we just discussed, waiting a long time for each step completely breaks your creative flow and makes experimentation cumbersome, frankly.
Yeah, you lose the momentum.
You do. Minimal latency, generating and editing in near real time, means you can rapidly try different ideas, refine your image through multiple small steps, and see the results instantly. It makes the editing process feel fluid and interactive, much more like using traditional creative software, but guided by text.
Okay, so those are the core capabilities. State-of-the-art text-to-image, combined with powerful in-context image-to-image editing covering character consistency, local and text editing, and style transfer, all designed to work iteratively and at high speed. Now, Black Forest Labs hasn't just released one model implementing this, though. They've released a suite of models under the FLUX.1 context name.
That's right. They've introduced different variants, each tailored slightly differently to different user needs or, priorities.
Tell us about them.
Okay, first there's FLUX.1 Context Pro. They describe this one as the pioneer for fast, iterative image editing. This is likely their primary offering, the one that embodies the full suite of capabilities we just outlined.
And this is the one that seems to combine everything we talked about, taking both text and image, doing local edits, character consistency, iterative editing, all at speed.
Yes, it's presented as a single integrated model that delivers local editing, generative in-context modifications, and classic text-to-image generation, all while maintaining their signature FLUX.1 quality. It's built to handle both text and reference images as inputs seamlessly, enabling those targeted edits and complex scene transformations based on that combined understanding.
And they make a pretty bold claim about its speed relative to other models.
They do. They state it operates up to an order of magnitude faster than previous state-of-the-art models on the tasks it's designed for.
An order of magnitude? That's 10 times faster.
Potentially, yeah. And they specifically call it a pioneer for iterative editing because they see it as the first model truly designed to allow users to build upon previous edits through multiple turns while effectively maintaining consistency.
Okay, that's Pro, focused on the core iterative editing workflow and speed. What's the difference with FLUX.1 Context Max?
So Max is described as offering maximum performance at high speed. This appears to be their variant pushing the boundaries on specific output quality metrics.
Okay, quality focus.
Right. It focuses on greatly improving prompt adherence, how accurately the model follows complex text instructions, as well as typography generation, which is notoriously difficult for AI, and achieving even higher consistency for editing compared to Pro.
Even more consistent.
That's the claim. The key is that it aims for these performance boosts without compromising on that high speed that defines the FLUX.1 models.
So Pro is the workhorse optimized for the overall interactive, iterative editing workflow at breakthrough speed, while Max is for users who prioritize absolute top-tier quality in areas like prompt following, text accuracy within images, and consistency while still getting the speed benefit.
That appears to be the intended distinction based on the descriptions. One optimized for the flow, perhaps, and the other for maximal fidelity and adherence within that flow.
Got it. Then there's a third variant, FLUX.1 Context Dev.
Right.
And the dev suffix suggests it's for developers, researchers, people who want to get under the hood a bit.
Yes, and importantly, Black Forest Labs highlights that this is an open weight variant. They state they deeply believe in open research and weight sharing as crucial for fostering safe technological innovation in AI.
Open weight, that's significant.
It is. This dev model is described as a lightweight 12B diffusion transformer. Actually a different type of architecture than the flow matching models, interestingly, but often very capable. It's specifically designed to be suitable for customization and is compatible with previous FLUX.1 dev inference code.
Okay, so open weight means researchers, startups, the broader AI community can download the model's parameters, examine how it works, potentially build upon it, fine-tune it for specific tasks, or integrate it into their own research and applications. It really democratizes access to the underlying tech, doesn't it?
Exactly. It's a move that encourages collaborative development and safety testing. This dev model was initially released in a private beta for research usage and safety evaluation, with plans for a broader public release later through their various partners.
And how can people access the Pro and Max models if they want to start using these capabilities right now?
They're primarily available through Black Forest Labs' ecosystem of partners. These include popular creative AI platforms that integrate the models into their user-facing tools. Names like CreAI, FreePic, Lightrix, OpenArt, and Leonardo AI.
Okay, familiar names for people in the space.
Yeah. Additionally, the underlying API access for developers and businesses is provided by infrastructure partners who handle the technical heavy lifting of running these large models. Partners like FAL, Replicate, Runware, DataCrunch, Together AI, and Comfy Audio.
So different models for different purposes, Pro, Max, Dev, and multiple access points depending on whether you're an end user on a creative platform or a developer integrating via an API. That makes sense.
Sure.
How did Black Forest Labs evaluate these models? What kind of performance numbers or claims are they reporting to back up these capabilities?
Well, they conducted an extensive performance evaluation to benchmark FLUX.1 context against other leading models. And interestingly, to do this, they found they needed a new way to measure the specific in-context capabilities of their models.
Because existing benchmarks didn't quite capture it.
Apparently not well enough. So they compiled a new benchmark called Context Bench.
Context bench. Okay. Is that specifically designed to test things like character consistency and local editing across multiple turns?
Yes, that's exactly its purpose. It's described as a benchmark for both text-to-image generation and, crucially, image-to-image generation, compiled from crowdsourced, real-world use cases.
Real-world use cases, so not just abstract tests.
Right. This suggests it includes prompts and scenarios that reflect how creators actually want to use these tools, not just generating random images, but performing specific edits or maintaining consistency. And Black Forest Labs states they plan to release this benchmark publicly in the future, which would be a valuable resource for the entire field.
That's good to know. Standardized, relevant benchmarks are essential for objectively comparing different AI models and understanding their true capabilities and weaknesses. So what did their evaluation using Context Bench and other metrics show?
They evaluated the models, specifically FLUX.1 Context Pro, across 6 distinct in-context image generation tasks drawn from Context Bench. The key finding they highlight is that Pro consistently ranks among the top performers across all 6 of these tasks when compared to competing state-of-the-art models.
Consistently top. Were there specific areas within those 6 tasks where it particularly excelled, aligning with the key features they promote?
Yes, this is where it gets particularly interesting. They explicitly state that FLUX.1 Context Pro achieved the absolute highest scores, specifically in 2 critical areas: text editing and character preservation.
Ah, okay. That ties directly back to those major pain points and desired capabilities we discussed earlier. That's pretty strong validation from their internal testing that the model delivers on those specific promises, accurately changing text within images and maintaining character identity across changes.
It is. And they also focused heavily on evaluating speed, which is a core claim. The evaluation shows that FLUX.1 context models consistently and significantly outperform competing state-of-the-art models in inference speed.
And that's for both classic text-to-image generation and the newer image editing tasks.
Both, yes.
So that claim about operating up to an order of magnitude faster holds up in their testing against current leaders.
According to their evaluation data and the graphs they show, yes. They demonstrate demonstrably lower latencies compared to competitors, which directly translates to that faster, more interactive user experience we talked about.
Makes sense.
They also evaluated FLUX.1 context on traditional text-image benchmarks, the ones that don't involve image inputs or context. And even there, they found competitive performance across standard quality dimensions like aesthetic appeal, prompt following, typography quality, even in pure generation, and overall realism.
Okay, so the performance evaluations, particularly the results on their new context bench focusing on in-context tasks, seem to validate the core claims about speed, text editing, and character consistency. While they do release a full tech report with all the deep statistical details for those who want to pore over them.
Yeah, for the really keen.
This summary gives us a clear picture of where FLUX.1 context aims to lead. So, with these capabilities and performance, where do they see this technology being used in the real world? What are the potential applications and use cases described in the sources?
Well, the sources list a wide and, frankly, exciting range of potential applications. They directly connect the technology's unique strengths, especially that in-context editing, consistency, and speed, to real-world needs in creative workflows.
So, bridging the tech to the task.
Exactly. The broad categories they mentioned cover everything from creative content creation and digital art to advertising design, educational materials, and essentially any situation that requires context-based or iterative image generation and modification.
Let's break down some of the specific examples they give, because this is where the potential really comes alive. Novel illustrations and covers for books or articles, for instance.
Yes, this is a great fit because the tool can potentially automate or significantly accelerate the process of generating contextual illustrations and character designs directly from text passages in a story or article.
Right.
Imagine an author writing a scene describing a character in a specific environment. This tool could help visualize that scene. And then, crucially for a book, maintain that character's consistent appearance in subsequent illustrations depicting them in different parts of the story. That character consistency capability is absolutely key here.
That makes complete sense. It removes a major bottleneck for authors or maybe small publishers who might not have access to dedicated illustrators for every single scene. What about AI comics and visual script development? This seems like another obvious fit for the iterative and consistency features.
Absolutely. This leverages the model's ability to create sequential images and maintain visual continuity. You could use text descriptions of comic panels or storyboard shots to generate the initial images.
Get the first pass.
Get the first pass, exactly. And then use the iterative editing capabilities to refine expressions, poses, or add specific details. The character consistency and style consistency features would be vital for maintaining a coherent visual narrative flow across panels or scenes for a comic or an animation sketch.
Right. You absolutely need the same characters acting and reacting consistently across different frames. Brand content and marketing is another area they highlight.
Here, the power lies in developing scenario-based visuals directly for marketing copy, brand guidelines, or maybe even specific product shots. You could take an image of a product.
Your actual product.
Your actual product, yeah. And generate variations showing it in different settings, being used by different people while maintaining the product's appearance, crucially, or with different textual overlays for A/B testing, perhaps.
Ah, interesting.
This helps develop visuals that enhance emotional expression and resonate with target users, ensuring the look and feel consistently align with the brand's identity and messaging. And that includes incorporating specific text changes on packaging or signs using the text editing feature we talked about.
That could drastically speed up the creation of marketing assets and allow for much more rapid iteration on visual themes. And what about educational visualization? This sounds potentially really impactful.
This is a potentially transformative application, I think. It could significantly assist teachers, textbook creators, or online course developers in transforming abstract concepts, things that are hard to draw or find existing images for, into concrete, easy-to-understand visuals.
Like scientific processes or historical events.
Exactly. Imagine explaining a complex scientific principle, a historical event, or an abstract mathematical concept, and being able to instantly generate a visual that illustrates it within the specific context of the lesson or explanation. This could greatly improve teaching engagement and student comprehension by providing immediate, tailored visual aids.
That could make learning much more accessible and engaging, especially for visual learners. And of course, general creative uses like rapid ideation, drafting, creating mood boards, and conceptual design are still very much on the table, now just enhanced by the speed and editing flexibility.
Absolutely. Anywhere you need to translate ideas into visuals quickly, explore variations, or build upon existing visual starting points, it just makes that process smoother.
Okay, so we have a good grasp of what FLUX.1 context is and what it can do, with specific examples of its capabilities and potential uses. But how does it actually achieve this? The sources touch on the underlying mechanisms and why it feels so effective, sometimes even, magical in its understanding.
Well, they attribute it to the use of deep learning models, specifically the generative flow matching models we discussed earlier, combined with sophisticated techniques for understanding the input. But the core mechanism that enables the context power seems to revolve heavily around deep context recognition and smart visual association.
So it's not just performing image manipulations based on simple rules or keywords. It's trying to understand the meaning and the relationships between elements in the image and the desired change in the prompt. It's reading the room, so to speak.
Exactly, reading the visual room. They emphasize its ability to understand the intent behind your combined text and image inputs. They say the FLUX.1 context reads the context of your image in your prompt, so that when you give it an instruction, the resulting edits just make sense in the overall picture. This level of understanding is what allows for those precise local edits and coherent global changes.
That sounds like it's aiming for a much higher level of semantic understanding, connecting the meaning of words and phrases to the visual information than previous generations of models might have had.
That's definitely the goal. They talk specifically about achieving high semantic accuracy and image coherence. For an edit to just make sense, the model needs to understand the relationship between objects, characters, actions, and the overall scene, as well as the nuances in your instructions, to make changes that are visually and logically consistent within that context.
And how does it acquire this deep context and semantic understanding? Is it just from being trained on massive data sets, or is there something more?
According to the sources, it specifically utilizes large language models, LLMs, as part of its architecture.
Ah, LLMs are involved.
Yes. To help pinpoint key plot points, object relationships, emotional undertones, and even analyze sentence structure and logic from your text input. It then combines this rich understanding derived from language with the visual information it extracts from the input image.
So it's using the powerful reasoning and understanding capabilities of LLMs to inform how it interprets and modifies the visual world. That makes a lot of sense for grasping complex instructions or understanding the narrative context of an image used in sequence.
Yes, it's a truly multimodal approach where the language understanding component guides the visual generation editing component. And the resulting benefits they list stem directly from this. Edits that are intelligent and just make sense. The ability to write less, create more, because you don't need to over-explain every single detail.
The model infers.
The model is supposed to infer based on context, yes, and having the confidence to explore because it can handle both broad, sweeping instructions, change the background, and very precise, targeted ones, make her laugh, while maintaining coherence.
And all of this contributes to creating visually consistent compositions that truly fit the overall context of your input image and instructions, circling back to that powerful idea of shaping your images, your words, your world.
They sum this up with the concept of contextual precision, the ability to produce more accurate and relevant images and edits based on a comprehensive semantic understanding of the combined inputs. They also mention extensive customization control, implying that beyond the text instructions, users can fine-tune aspects like composition layout, mood, character appearance details, and color styles via parameter adjustment.
Ah, like sliders or settings.
Presumably available through the API or Playground, yeah, allowing for highly personalized creations that match specific artistic or design needs.
So it sounds like a sophisticated system combining advanced generative models with language understanding to achieve a new level of context-aware visual interaction. That does start to explain the magic feeling people might get. But like any cutting-edge technology, it's important to be aware of its current frontiers and limitations. The sources are quite transparent about specific failure cases they've identified, which is good.
They are, and that transparency is really helpful for users to understand where the technology might still stumble or where you might need to be careful. Black Forest Labs lists specific limitations in the current implementation of Flux 10.1 context that users might encounter.
Okay, so what are some of these limitations? Where does it kind of fall short sometimes?
Well, one is the potential for visual artifacts from excessive multi-turn editing. While the model excels at iterative editing compared to predecessors, they note that image quality can still gradually degrade or introduce unwanted artifacts after too many sequential edits building upon each other.
So you can't just keep editing forever without consequences.
Apparently not. They specifically show an illustration where degradation becomes visible after around 6 iterative edits, indicating there's a practical limit to how many layers of modification you can apply before fidelity starts to suffer.
That makes sense. Each edit is a transformation, and applying many transformations in sequence can compound errors or inconsistencies, much like repeatedly copying a photocopy might degrade it slightly each time. So there's a current limit to the depth of that iterative refinement.
Exactly. Another limitation they mention is occasional failure to follow instructions accurately. While generally strong in prompt adherence, they state that in rare cases, the model might still misunderstand or simply ignore specific requirements in the prompt.
Especially maybe with very complex or contradictory instructions.
That seems likely, yeah. So still something to be aware of. It's powerful, but not omniscient or perfectly obedient to every possible command.
Right. What else?
They also note limited world knowledge, which is a common challenge for AI models trained on static data sets. This can affect the model's ability to generate or edit content that requires very specific, nuanced, or up-to-date facts about the real world or niche domains.
So it might struggle with historical accuracy in details, specific cultural references, or very precise geographical features it wasn't trained on.
Potentially, yes. It might not know certain things. And finally, one tied back to the technical underpinnings. They mention artifacts from the distillation process.
Distillation?
Yeah.
That's making smaller models from bigger ones.
Exactly. Distillation is a technique often used to create smaller, faster models from larger ones, essentially compressing the knowledge. While beneficial for speed and efficiency, this compression can sometimes result in subtle visual artifacts that impact the final output fidelity compared to a non-distilled, larger model might have produced.
Okay, so while it's incredibly powerful and innovative in its core capabilities, it's not a perfect, limitless tool. There are specific ways it can still fail or show weaknesses, particularly with very heavy, multi-layered iterative use, extremely complex or niche instructions, or needing very specific, detailed, real-world knowledge. Knowing these limitations is just as important as knowing the capabilities for managing expectations and workflow, right?
Agreed. Understanding where the current boundaries lie helps users apply the tool effectively and know when they might need to switch approaches or maybe apply manual refinements afterwards. And Black Forest Labs and their partners are making these capabilities accessible for users to actually experiment with and discover both the strengths and limitations for themselves.
So how can people access and try out FLUX.1 Kontext? Where can they get their hands on it?
Well, Black Forest Labs has introduced the BFL Playground. This is a dedicated web interface designed for developers, teams, and even curious individuals to test the models directly without needing complex technical integration or setting up development environments.
So you can just go to a website and start playing with it using the combined text and image inputs, like upload a photo and type instructions.
Yes, it's presented as a streamlined way to interact with the API backend via a user-friendly interface. It's available at playground.bfl.ai and is intended specifically for validating potential use cases, demonstrating the model's capabilities to colleagues or stakeholders, and experimenting in real time with different prompts and images before potentially committing to a full API implementation. It serves as an entry point to explore what the BFL API can do.
That sounds like the easiest way for someone interested to just jump in and see firsthand what it can do with their own images and ideas. And as we mentioned earlier, the Pro and Max models are also integrated into various partner platforms that many creative users might already be using.
Yes, exactly. You can access the power of FLUX.1 Kontext through popular creative platforms like CreAI, FreePic, Lightricks, OpenArt, and Leonardo AI, who have integrated these models into their user interfaces and workflows.
So if you already use one of those,
you might already have access or will soon. And for businesses or developers who want direct programmatic access, the underlying API is available via those infrastructure partners we listed, including FAL, Replicate, Runware, DataCrunch, Together AI, and Comfy.org, who handle the model deployment and scaling.
And the open weight dev model, how will that become available eventually?
That's currently in a private beta phase, primarily for research and safety partners, but the plan is for it to be distributed through partners focused on open models and developer access like FAL, Replicate, Runware, DataCrunch, Together AI, and also Hugging Face upon its public release.
Hugging Face, okay. So there are multiple avenues, from a simple web playground for quick tests to integrating via API partners for large-scale applications, depending on your technical needs and desired workflow. It seems like they've built a pretty comprehensive ecosystem for deployment.
They definitely have. The multi-tier partner approach ensures different types of users can access the technology in the way that best suits them.
All right, we've covered what FLUX.1 Kontext is, its key capabilities, including that powerful iterative and in-context editing with text and images, the different models available, the performance claims validated by their new benchmark, its current limitations, and how to access it. Let's bring it back to the listener one more time.
Yeah.
Why does this all matter to you? What are the broader implications of this technology for creativity, work, or just interacting with visual media?
I think this technology represents a pretty significant, almost foundational step forward in how we can interact with AI for visual creation. It's fundamentally moving AI image tools beyond just describing an image you want and getting a static result.
The old prompt and pray method.
Kind of, yeah. Towards an active, iterative, and context-aware process of manipulating, refining, and building upon existing images and concepts. It's less about asking AI to imagine something from scratch, and maybe more about collaborating with AI to shape your existing visual ideas.
That focus on context and consistency really seems like the core innovation that unlocks new possibilities. As you said, previous models could generate stunning single images, but maintaining a consistent character, style, or even just a specific object across multiple images, or iterating on a design without losing fidelity, that was a major challenge that often required manual workarounds or just wasn't feasible at all.
Precisely. By directly addressing those key challenges, especially the consistency required for iterative edits and maintaining identity across different visual scenarios, FLUX.1 Context makes AI image generation far more practical and useful for structured creative tasks. Think about the potential for streamlining workflows and creating comics, generating consistent illustrations for a series, developing character art for games or animation concepts, or ensuring consistent visual branding across different marketing assets. It makes AI a more reliable partner in multi-image projects.
And those significant speed improvements we discussed, enabling interactive editing with minimal latency that changes the creative process itself, doesn't it? You're not submitting a job and waiting. You're fluidly experimenting and refining in real time. That responsiveness is crucial for creative flow.
Absolutely. The lower creative barriers are also a major implication. The sources highlight that you can now create high-quality, complex, contextually relevant images using only text descriptions combined with an existing image, without necessarily needing traditional art skills or expertise in complex software suites like Photoshop. This could open up visual expression and communication to a much wider audience, whether it's a small business owner creating marketing materials, a teacher developing custom visual aids for a lesson, a writer visualizing characters, or just someone exploring personal artistic ideas who doesn't have traditional drawing skills.
And the existence of an open-weight dev model, that's not just a technical detail. It has broader implications for the AI field itself, right?
That definitely suggests a potential for significant community-driven innovation and further research built on Black Forest Labs' foundation. Open models often accelerate progress in unforeseen ways as people adapt them, combine them with other technologies, and push their boundaries. It's a signal that this technology might not just be a proprietary tool, but potentially a cornerstone for future developments in multimodal AI interaction, perhaps even leading to new creative applications we can't fully imagine yet.
It also highlights the collaborative model they've adopted. You have Black Forest Labs building the core cutting-edge models, and then partners like FAL focusing on the, let's face it, difficult engineering challenge of scaling and serving that technology reliably and efficiently to users and businesses. It takes a village, or at least an ecosystem, to bring these complex tools from research to widespread usability.
Indeed. It shows the different layers of expertise required to make advanced AI accessible and practical.
So, summing up this deep dive then, FLUX Post-1 Context is a new suite of multimodal AI image models from Black Forest Labs based on generative flow matching. It's designed to excel at in-context generation and editing by taking both text and images as input.
Right, and its key strengths, backed by their evaluations, lie in enabling interactive speed, robust character and style consistency, and precise local and text editing. This particularly enables consistent iterative editing across multiple steps, which is a big deal.
It's available for experimentation through their own BFL playground and integrated into various popular creative platforms and developer APIs via their network of partners.
But it's important to remember it's still evolving. It has current limitations, particularly concerning image degradation after excessive iterative edits and occasional adherence issues with highly complex instructions or niche world knowledge. It's not magic, even if it feels like it sometimes.
Right. The core shift here is moving towards a more intuitive, iterative, and deeply context-aware way of creating visuals with AI. It's less about generating something from scratch based purely on words, and more about showing the AI what you mean using existing visuals, and then interactively shaping and refining it using both images and text. It's a move towards AI as a more collaborative, context-sensitive, creative partner.
And that brings us to a final provocative thought for you, the listener, to mull over as you consider the implications of these capabilities. Given the power of seamless iterative editing, the ability to maintain consistent characters and styles across different scenes, and the potential for faster, more fluid visual storytelling demonstrated by this technology, how might tools like FLUX.1 Context change not just how we create visual stories, but potentially how we consume or even think about sequential visual narratives?
Like comics, storyboards, animation pitches.
Or even personalized visual content flows in the future? Will the ease of creating variations, alternate paths, or consistent sequential imagery lead to entirely new forms of visual media or storytelling experiences down the line?
That's a fascinating question to consider. Thanks for joining us on this deep dive into FLUX.1 Context. We hope you feel significantly more informed, perhaps a little excited about this cutting-edge development in AI image generation.